Making those kinds of beautiful images that we get from radio telescopes requires a huge amount of processing power, and the more individual receivers that we have, the greater amount of processing power that is required. Each one of those receivers is going to be producing gigabytes and gigabytes of data. We need to take the data from each of those receivers, we need to combine it together lots and lots of times to produce these images. So the amount of processing power we have is one of the main design considerations when we're thinking about the scope of project that we can build and the kind of science and observations that we can do with it. So how are we going to know what kind of processing power we have to deal with? How can we budget for the right amount of processing power? Well, if you look at the history of computers and how their power has evolved over the last few decades, it's very, very clear that we would really be selling ourselves short by designing an SKA which we can process the data from with a computer that we can buy today. What we need to be doing is thinking about what kind of computing power will be available to us in around a decade's time when the SKA is finally nearing completion. If we look back at data over the last few decades, there is a very clear trend. There is a very clear exponential growth in computing power. So we actually have a very good idea of what computing power will be available to us in a decade's time and exactly how much that's going to cost, so that we can take up an appropriate part of our budget for the computing capacity. Okay, in this module we've explored the vital role that technology plays in scientific research. We've seen that new technologies almost inevitably lead to new discoveries, although perhaps not the ones that we were expecting to make. We've explored how radio telescopes work, the factors that go into designing them. Also looked at the SKA radio telescope in particular and how we're going to go about designing that to optimize it for the discoveries that we want to make. I'm really looking forward to the next module. We're going to be talking about the science that we're hoping to do with this square kilometre array. What are the big unanswered questions that we hope to answer? In order to find out a little bit more about the subject, I'm actually going to be talking to some of the researchers who hope to use the square kilometre array in their research into things like black holes and even the search for extraterrestrial intelligence. So I really hope that you can join me in finding out more about the amazing world of radio astronomy.